Hey fixers, and welcome to today's one-liner trick session. I think it's one-liner trick number 5 out of 50 or so. So I have a lot to go. I'm doing this session for the launch of my new Python one-liners book. So check out the book if you want to develop your one-liner superpower and be able to read every single line of code in the universe, at least in the Python universe. Good. So today we are addressing two features in one line of code, which is list comprehension and slicing. So they are kind of standard Python features, but you need to understand them by heart. So they are really relevant for any Python coder who want to thrive in the space and who want to improve his Python skills. So let's go into the practical examples. So say you are working as a financial analyst for a large bank and you are training a new machine learning model. Okay, so this is a common scenario, and like for example for stock price forecasting, and you have training data set of some real world stock prices, but your training data set is huge. Yeah, so it's very large, and the model training takes forever. And so if you run it on your computer at least, so you may have some servers on the bank where you can parallelize execution, but yeah, let's say you just want to try the model on your computer first in order to present it to your boss. So first you want to train a model, improve the model, then you can present it to your boss, and then you can request some more resources where you can train your model. So if usually it's one problem of machine learning is that it takes forever on your machine. If you have some realistically large data set, it takes forever. So this will really harm your progress, your encoding, and slows down your overall speed and progress towards a very effective machine learning model. So how can you accelerate this? By sampling the training data. Yeah, just reduce the training data, trainer data set, and usually nothing bad happens. Only the accuracy of the machine learning model will change. Sometimes it will improve. Sometimes it will actually get worse. Yeah. But of course, you can also like train your machine learning models and tweak the parameters of your machine learning model on a smaller data set, and then just use this model to predict on larger data sets. So this is perfectly possible, and oftentimes it's used. Okay, and in this example, we have in this one line we have a very simple example, like a minimum example. Say you have this data of some stock prices. Let's have them in order, and so this is a list of lists, obviously, and each consisting of 6 floats. Okay, here we have 6 float numbers, and each float value can be a daily stock price, for example. So we have like in a given day, say we have 5 or 6 stock prices, and on the next day we have again 6 stock prices. On the next day we have again 6 stock prices. This is how our model looks like, and obviously there are some fluctuations within the day, but if you are a serious investor, you don't care about these daily fluctuations. You only care about the longer term or even shorter term performances, but not micro term stock price performances, okay, or changes. So therefore, your idea is to sample every second value from each line. Okay, so you want to reduce the data set so that you can train your machine learning model faster and try out different models, play around with the parameters, and then of course if you have found something that looks promising, you can do it on the original larger data set. But here this is like a common problem. We just want to filter the data set. How do we do this in a single line of code? Yeah, say we want to create a sample of the data. We use list comprehension for this. List comprehension, is indicated by the 2 square brackets, opening and closing square brackets. So you create a new list basically with list comprehension. And now how does list comprehension look like? In the new list, you have some program, some mini program running that that adds new elements to your list, and now you have to define which elements to add to the list. And to do this, you have to define a certain expression and a certain context. Okay, so these are only placeholder values, as you may already have guessed. So the context is gives you an iterable so you iterate over an iterable. Basically, the return value is not an iterable. This would not be precise to say, but it's so you define a loop variable. Can have any name, like for I in something, and then in something must be an iterable. Okay, and here it's like a one line for loop, you can say. So here you define the context. So you iterate over a number of values. This is the goal here in the context. And what values do we iterate over? So we iterate over all lines in the price data set. Okay, so therefore this variable line is now our loop variable, and it first takes on this value, second it takes on this value, third this value, and fourth this value. So it takes the whole row of your two-dimensional data at a time. And now we want to change this row. Yeah, so we want to have a list of lists. So the outer square bracket already ensures that we have a list, and here we have a list as the variable name. So if we just put in line here, we would have exactly the same data. Okay, so we would have a list of list again. So if let's quickly print the result of this code snippet. Yeah, you see now we have a list of lists, and it's exactly the same data set. Okay, so if I make this a bit smaller so that you can see all the data, yeah, here you see. So this is exactly the first line as previously, the second line, the third line. So basically here we iterate over all lines in the price and just put the line into our list. So this is like the our raw construct to sample the data. And now we want to do something with the line. Okay, so this is our expression. Currently it's only the identity expression, so it simply adds the whole line to the list as a list element. So we have a list of lists, obviously, but we don't want to have the whole line. We want to have only a part of the line. We want to have only every other element. How can we get every other element from a list? So let's define a dummy list like 1, 2, 3, 4, 5. And we want to have every other element, so then we simply use slicing. Slicing has the general notation is start, stop, step. Okay, and we have the colon delimiter. So we define a start index, a stop index, and a step size. So slicing allows us to carve out a subsequence of your original sequence. It works for strings, it works for lists. And in this case, we want to have the default start index, the default stop index, because we are perfectly happy with the whole list, but we want to have only every other element, so only every second element, which is like you can use 2 here to create a list and sample only every other element from the list. Okay, so we have 1, 3, 5, and so on. Okay, so this is our goal. So if you print this, you see we have 1, 3, 5 as the result value. Okay, so this allows us to sample every other element. So we simply use this here in our expression. So we can modify our expression. We can have the line. We can modify the line. Just take every other element from the line, and that's it. So if you print this, we get the same list as before, but only with 3 elements instead of 6 elements. So we only take every other element. So this would be the first one, this would be the second one, and this would be the third one. Okay, and we skip the remaining elements in the list. And this gives us simply also a list of stock prices, but only 3 stock prices per day instead of 6 stock prices per day. So very simple one-liner, but no worries, they will get harder. But in order for you to understand harder one-liners, you first need to understand the simple one-liners, okay? Because they build on each other. So in harder one-liners, we will have multiple list comprehensions building on top of each other, or even nested list comprehensions. So you really need to understand list comprehension thoroughly before you can understand the advanced one-liner we will look at. Okay, thanks for listening to this video, and see you in the next video. Bye.